What if the Earth suddenly stopped spinning? The initial catastrophe. If the Earth were to halt its spin abruptly, the initial effects would be catastrophic. At the equator, the surface of Earth and everything on it is moving at approximately 465 meters per second to keep pace with the planet's rotation. Closer to the poles, this speed decreases significantly, but the momentum is still considerable. Violent ejection. At the moment of deceleration, everything not anchored to the surface would be flung eastward at the prevailing rotational speed. In San Francisco, this would mean an eastward launch at roughly 368 meters per second. This sudden stop would cause our bodies, along with any buildings and other loose objects, to become supersonic projectiles, wreaking havoc on an unprecedented scale. Absolute destruction. Airplanes in flight might stand a better chance, as they could attempt to navigate the resulting turbulent storms, but only temporarily. The impacts on the surface would turn runways into the entranceways of a global graveyard. Astronauts on the International Space Station might fare the best, given their distance from the immediate chaos. However, they would return to a nearly uninhabitable Earth. Secondary environmental disasters. The absence of Earth's rotation would not only wreak havoc on its surface, but also lead to a series of environmental disasters. Unrelenting winds. At latitudes far from the poles, winds moving with the momentum of the previously rotating Earth would tear across the planet's surface, triggering storms with the ferocity of atomic bomb detonations. These storms would cause significant erosion, fires, and unparalleled damage to the landscape. Frozen sun and enormous tsunamis. One of the more surreal effects would be the apparent freezing of the sun in the sky. Days and nights would cease to be 24 hours long, extending instead to 365 days or more. This radical change would have dramatic effects on the climate and ecosystems around the globe. The oceans, no longer held in place by inertia, would surge onto land in colossal tsunamis. Magnetic field dissipation. Additionally, the cessation of Earth's spin would halt the motion of its molten core, which generates our protective magnetic field. Without this shield, Earth would be subjected to deadly amounts of ionizing radiation from the sun, rendering the surface hostile to most forms of life. Why we don't feel the spin. If the Earth is spinning at such incredible speeds, why don't we feel dizzy? The answer lies in the gradual change in velocity. Our planet's immense size means that the change in velocity as it spins is incredibly slight, akin to a car making a wide turn over several thousand miles. This gradual change is too minuscule to register in our sensory perception. Time in Earth's spin. Accurate timekeeping is intricately tied to the Earth's spin. The second is defined by atomic clocks, which measure the oscillations of cesium atoms. This definition is necessary because the Earth's rotation is too irregular for precise time measurement. Atomic timekeeping. Atomic clocks are the epitome of precision. They count the oscillations of cesium atoms consistently, which allows us to define 1 second as exactly 9,192,631,770 oscillations. This precision is necessary for applications such as GPS, which rely on extremely accurate time measurements, adjusting for errors. Despite the Earth's irregular spin, seconds must be consistent. Scientists keep track of the Earth's rotation by observing distant stars and quasars. When discrepancies are noted, leap seconds are added or subtracted from our clocks to stay synchronized with Earth's rotation. Conclusion. The hypothetical cessation of Earth's rotation unfolds a dramatic tableau of destruction and environmental upheaval, underscoring the critical role our planet's spin plays in maintaining life. As it stands, Earth's spin does more than just define day and night. It ensures our stability, regulates weight, and forms the backbone of precise timekeeping.